probably seen this chart a couple of times. I might have spoken about it earlier myself. But the idea here is that there's a data model that basically applies across all of the different kinds of access PHYs. It kind of pulls out all the common things that you do over and over again. It has plugins because the PHYs don't all get run the same way. And then it takes that common data model and provides it upwards toward SDN controllers or even legacy, OSS, BSS systems using standard interfaces like NetConf and OpenFlow. So, what would we do next? Well, one of the things that we think make a lot of sense at the physical layer is, now that we've got a way to abstract it well, let's see if we can't collect more interfaces at the bottom. So AT&T has already been kind of lobbying hard on G.fast. It looks like there are lots of carriers that are interested in that. It comes up fairly common in telcos. But there's other things that look really interesting as well. So fixed wireless, everybody's been talking about 5G and fixed wireless. That looks like an interesting area where we could have things that plug into both of them. Enterprise Ethernet is not just your plain Ethernet port off of a Trident or a Tomahawk chip. It often includes things like TWAMP and timestamps and Ethernet OEM that you don't typically find in merchant silicon. And so there's an idea here that you could create sort of a little Ethernet layer plus to help deal with carrier Ethernet. And then there's DOCSIS, right? Even maybe I made it too warm. So they're fixing it, I guess. So what I understand is that the MSOs who are also part of ONF have been working on their version of CORD, which some have called HERD, for head-end re-architected as a data center. And it may make sense for Volta to work not only for telco type PHYs, but also for DOCSIS type PHYs. So a couple of things that we also see are key deployment models. So the one that you've heard about a whole lot is the first one, that you have a completely disaggregated system, that you run the management and control software, the whole Volta stack, and as well as ONOS and applications in adjacent compute next to the boxes that it manages. But I've also heard from the industry that sometimes it makes sense to try to create or reintegrate this disaggregated system in an integrated device. And if you look at the open spec hardware from OCP, it includes the option to keep your CPU inside the box. And that CPU obviously could run Volta and or the whole stack for that ONOS. And I think, Saraf, I think you actually spoke to that, how you could create that entire vertically integrated OLT white box by running that really slim instance of the entire stack right inside the box. Okay, so where else could we go? There's a virtual service gateway in Core today. The virtual service gateway it's named something different. It's not a BNG, it's not a BRAS, it's not a SAE gateway or a P gateway. The reason, well, originally it was part of what I call the concept car, meaning that we wanted to show how you could pull all of the functions that needed to run in x86 or in a common compute platform into one location. And so we pulled them out of lots of different network elements. We pulled them out of the BNG, but we also pulled it out of the residential gateway. And so the NAT functions that were in the residential gateway got pulled in to the virtual service gateway. And so that meant that there was only one hop necessary through a generic server in order to provide the end-to-end port system. Lots of carriers are not so keen on this VSG, right? It's kind of forward-looking. It has this sort of cloud bursting for consumers notion, and it's really kind of, I think, where the industry ought to be going, personally. But lots of carriers, maybe including my own, say, well, we're very conservative, and we'd like to stay with our VNG for at least a few more years. So I think that having a software VBNG and or a hardware VBNG is a really good complement. In fact, I think I heard it in the previous talk from Cord in China. One of the presenters there was talking about creating VBNG software for Cord. So there's different ways that it can happen. Within AT&T, when we went to the field trial, we created a software VBNG, and that's something we hope to be able to bring back to the Cord community. There's also a possibility to create a SDN-based BNG, meaning I'll have a control plane application and it will direct some type of merchant silicon. So that may well be a really interesting thing to do. And we believe that the kinds of silicon you might find in some kinds of Tor switches, and also the aggregation chip that we used in the design for the XGS-PON OLT, are very capable of providing BNG-like functions. So both of those, I'm kind of alluding to a Qumran class chip, and as many of you know, that would mean tens of thousands of queues. It would mean hierarchical scheduling and complex scheduling. It's a very, very capable piece of silicon and could be controlled to do most, if not all, BNG functions. And then finally, what we find is that broadband network gateways also provide other functions besides, they provide policy enforcement. They also do a lot of call protocol helpers. They might terminate various types of in-cap, like PPPoE comes to mind, still in use in a lot of networks around the world. And one really important thing is they wind up doing a lot of counting. So usually, the service providers are selling something, and if you're not counting what you're giving, then you're not in a good place to be able to provide bills for what you provide. So work on BNG, I think, is definitely a fertile area going forward for our Cord. So now let's go away from the BNG. There's already a set of control plane applications within our Cord. Well, what other ones might make sense, or which ones do we have now that might need to be matured a bit more? So the first one is the attachment control. If the AT&T deployment has 802.1x used to authenticate an end user subscriber. Other carriers sometimes use different protocols, but generally, they don't just let anyone jump on the network. There's usually some type of authentication and attachment, AAA function, if you will, in use in most places around the world. And one size doesn't fit all. So I believe that that's an area where sort of building out or building up the capabilities for AAA and attachment control makes a lot of sense. Multicast, it's basic and it's in our Cord today, but the multicast that I'm aware of out in the industry includes blacklists and white lists and gray lists and all kinds of policy that dictates exactly what IGMP groups you can join. It's a lot of times how different groups of channels get set up for IPTV and who's allowed to attune to which ones are often done in terms of policies that are controlling the IGMP or the multicast infrastructure. Forwarding plane configuration, right now our Cord, I think, is just one QoS, one best effort serves all, right? But we know that you need to be able to provide and have different levels of QoS. It's very common to have an expedited forwarding layer for voice over IP and a DiffServ or assured forwarding layer for IPTV services. If you're not all into the new Cord architecture, then you may find that you need to kind of interwork with legacy, either operation systems or other systems that are in your network. And it can be either network devices or they can be OSS, BSS class things. One of the things that happens today in lots of carrier networks is that the access portion of the network has to enrich certain protocols that flow through it. So if I have a DHCP message that's being sent to between a household and a DHCP server, one of the things that my access node might do is put into the DHCP the agent circuit ID, or the identifier that this message is coming from a particular port or a particular customer or a particular phone queue. And there's lots of ways that gets done. And so we might wind up looking for ways to build that out and to enrich that part of the system. DHCP is kind of, well, can apply to both v4 and v6, but the other items here are really around IPv6. There's a number of different, what I would call security mechanisms, which are very common in access networks today, that manage and control the use of ARP and manage and control the use of a DAD in order to make sure people don't sort of snatch the MAC address from their neighbor or do other unsavory things. OANM as a mechanism to understand where we might have faults in a network and to be able to determine them quickly, something that we know is part of the architecture for CORD, but needs to be kind of built out as well. And then the radius and LDAP backends, for a lot of carriers, deploying a CORD system is not going to mean replacing your backend radius or LDAP systems. Those are huge, and you know how that is, right? That's off to the side, not something we want to replace along with bringing CORD in. However, they have existing interfaces, and it should be easy to sort of manipulate CORD, our CORD, so that it plays nice with these types of things. All right. And then next to the last slide is operations tools. So within AT&T, we think that there's a lot to be done for offline install. I don't know how many times. Okay, how many people have installed CORD? Well, that's pretty good. And how many have tried to install CORD in a central office? Well, let me tell you. There's no internet in a central office. And so you basically have to take your server out to some place where they have internet and then haul them back. CORD right now is really made to be, using its Git repositories and whatnot and pull in the most recent things. When you're in this sort of secured bunker we call a CO with no, it's a security reason that there's no internet inside the CO. And then trying to install these things that are trying to go out to the internet can be a big hassle. So let me not forget that. And then there's the hit list, right? We're looking for ways to be able to upgrade, restart, change the infrastructure, add capacity and whatnot, all without having to restart the system from zero again. And finally, the operations people need to have some way to kind of have an inspection pane or a pane of glass that makes them confident that it's working the way it should work. And then automation interfaces, this is sort of my cute way of saying we have this ONAP system and it likes to automate the service across the entire AT&T network, and it ought to be able to connect into our CORD as well. So, to kind of sum it up, we think that the longer term items might include flexibility for adopting environments. Some environments might be part new equipment, part old equipment, or you might want bits of CORD or all of CORD. And so having that flexibility to pull it together or take it apart in some cases is really important. It'd be really nice to see more VNFs for customer services. I heard a lot of times today that the thing that's really going to sell or drive the adoption of CORD is not necessarily the platform. That's great. There's operational CapEx and OpEx savings, but the new applications, the VNFs that you plug in are the real value at the end of the day. We should kind of see some more of those coming along. And then in the longer term, the BNG, which I talked about earlier, might have some really good, what I would call overlaps or commonality with SAE gateways for mobility. So when we talk about a multi-access core CORD or R plus M CORD, having a gateway function that did both with the same infrastructure might be really good. And then what we've noticed is that a lot of the VOLTA layer and a lot of the ONOS layer are architected in highly similar ways, and I'm sure that was no accident. And is there an opportunity here to kind of do some kind of optimization or deduplication in that space? So that was kind of a whirlwind, but those are kind of our views from AT&T about our CORD looking forward. And I think now I'm going to sort of take that and transition and invite up my colleague here, Manuel Paul from Deutsche Telekom, and let him kind of give his sort of views on the matter. So thank you.
So just starting maybe a little bit bottom up, since this was the running order when Tom finished with operation management. So certainly we had a nice experience with Core 1.0 and then a bit of the follow-up versions. And we see already improvements in the build process. So that was, I think, already a quite good thing to see. And now we just presented the roadmap, so there's going to be, of course, further improvements along the way. And also, we believe there should be some commonalities across all the different use cases as they are getting deployed on Core. But more specifically, also, it would be nice, I think, to think about a process that is not just lightweight. So we heard about light and right, I think, at least probably some of you, if you're following the core development and the release map and the roadmap, but looking at what could be done to have all of these components in a tool chain that allows to simplify and reduce a little bit of the options and of the tools that are being used. Certainly these are all cutting edge, and just for the deployment, I think it needs to be as simple as possible. And for the automation, that's another story where probably work here at ONF and Ford plugs very nicely into the OSS stacks that are just to be seen on top, right? For example, ONUP. So we at DT, we haven't made our minds yet whether we should put a focus on that one at this point. But in any case, we are looking for a fully automated network service management as well. And so lifecycle management automation is really important as well. So again, there are some questions added which are connected to what I call the call for community engagement, since all of these actually are items that we see relevant to be considered, and of course would be very happy to discuss with the community. And another one where we see that we could benefit, or we have a benefit when we work together on taking some of the some of the applications that we currently run as sort of the base network service enabling or subscriber session management functions. And here we've been looking into what to do with them, what would be best, have them tightly integrated with the controller platform. And one of these obviously is Honors, which is very optimized for the use cases currently in Core, which are all motivated by network operator requirements, right? And particularly RCord, that is our current focus. Actually has a number of them, but even looking forward to multi-access cord and M-cord, there are going to be more applications that need to be onboarded, that need to run as a control plane on such a cord POD and actually control the resources and the everything that goes on. So should these be standalone, or should they be connected to a controller platform? Certainly, if there's a controller platform available that provides for high availability, then that provides a big benefit, since all of these applications are using data, and some of them even are stateful. So looking at databases and having this whole thing orchestrated as a distributed system is, of course, a requirement when you want to be high available. So it's not just enough to build up a prototype with an SQL database, but it needs to be something that can be really brought into, let's not say carrier grade, because it sounds old-fashioned, but that is something production grade, right? So this is one point on the control plane. Looking at the user plane, and Tom had the picture with a BNG here in front of us. So I was asking whether it needs to be that box, or if you look at hardware, and also as discussed this morning, there's good opportunity in making use, of course, of hardware. And we at DT are at this point not strong believers into
a virtual subscriber gateway simply because of performance and some of the issues that might be still around with the generic compute. On the other hand, certainly there might be functions that are very useful to be virtualized as such. And otherwise, I call them softwareized, right? So definitely controlled by SDN applications. But the implementations should be, at least for these use cases that we are currently seeing, that include the support of PPPoE as one of the protocols for the subscriber edge functionality, and to connect also to our existing platforms. Or Radius was mentioned already, right, as such existing platform control. So these should be using programmable hardware, and that is also real SDN, I believe, in that case. Yeah, and then getting now in principle down to the bottom. So that is then the metal, or close above the metal. And here, when we look at Volta, which we believe is really a great blueprint for hardware abstraction. In that case, it takes hardware abstraction into the access network domain, which is really new and really a benefit to disaggregate. And when we look at what we are seeing as focus, we focus not just on XGS-PON for Volta, but also for GPON, meaning that we are going to use Volta, and we are interested in evolving it, but also we would like to make use of GPON equipment and not just XGS-PON, which is just a matter of network requirement. So then looking at Volta, right, and G.fast as fiber to the building, FTTB use case that we need to support. We're actually looking at the same point that Tom discussed. So there's ONOS, right, to work with abstracted and logical ports. So Volta kind of creates a big distributed, or well, actually using a distributed concept to abstract all of the resources and present this all as an SDN switch, so with an abstraction. But there's a lot of similarity in the architectures, obviously, since this is an abstraction layer, right, with northbound and southbound APIs. So is there some benefit in maybe looking at how to deduplicate and bring together these platforms, since they are evolving into microservices anyway? So that is another point that we brought up as a proposal for consideration to the community. And so, as said, all of these are points where we'd like to get feedback and discussion on. So thanks very much. And Tom, if you would like to get back on stage with me, I don't know if we have time for some questions, or if I've...
We have time for a couple of questions.
Great. Yeah.
Actually, even if Sergio is here, you might want to start setting up. Sergio? Not here yet. Okay, so we certainly have time for more questions. Yep. Hang on to the mic.
Okay, we do that. So are there any questions to Tom or myself?
And hearing none.
Yeah. Okay, that was easy.
Somebody has to be first.
Yeah. So what do people think about? What do people think about, for example, ONOS and Volta architectures? So is there?
How about
yeah.
questions? Tom, it's a question to you.
Uh-oh.
In your slides, one slide is I forgot it's number 5 or 6. It's on the very last bullet. It talk about the maturity. I didn't hear the more details. So.
Okay, so yeah, I do. There was a bullet on maturity. I thought that was kind of obvious. So, is Larry here? No, then I disagree with Larry. This is not a Halo car. A Halo car is something you can buy with a warranty and an owner's manual, and you can take it to the dealership to get it fixed. Right? I think we still have, and Guru has said this often, pre-commercial software that's coming out of ONF. I claim that's still the concept car, and that we do have that last bit of maturity. We are looking for the community, the vendor community, to step up into kind of bringing the whole R-Cord from the open source concept into products and services that can be bought in the commercially.
In other words, not only the car needs some work, but we also need to.
That's right. That's exactly right. Thank you, Thomas. All right. And I think well, since nobody's, I'll keep talking. You saw my list of different apps from Onos, right? That I think that a lot of these apps are sort of really good examples. They're excellent for kicking the tires in the labs, but you'll find that when you want to deploy it in a carrier's network, there'll be requirements from DT. They have their own ideas about how multicast should work. There'll be requirements from AT&T. They'll have things about how multicast should work, and then you'll find different carriers will look for different tweaks in the system, and that's really part of the maturity. If you look at today's vertically integrated boxes, and we often make jokes that they have 1,400 features, and any single carrier only uses maybe 40 of them, right? Well, there's a reason that there's 1,400 features. It's because between the two of us, we agree about 4 or 5, and the rest are all unique. So part of the maturity is gaining, either convincing us to do things more alike, which you have a chance at now, or building out so that it handles all of that diversity.
I have a quick question on that same topic.
Mm-hmm.
Do you see it as a function of the use case steering team to come up with some sort of consensus?
Gosh.
To converge on at least some subset of such applications?
So Tom,
Whether they're on platform or off
yeah.
platform, meaning that integrated or somewhere else?
So Thomas was just asking whether I thought that this was something the use case steering team should bring in. And frankly, my answer is no. That I think that what the use case steering team should bring in is what I'd call broad brush use cases. What is the next big area that requires lots of work to point a Cord implementation to? Frankly, I think that end users, the community, even the commercialization folks have the opportunity to do the tweaks, the little things, the fact that, you might want a policy hit when you do a multicast join and we might not. And that is a fairly, what I would call in the open source community, a fairly minor change to the logic in the program that can be handled without having to go back and put every minutia into the core or into the...
That does presume that there is some sort of infrastructure that represents the application in the abstract, then we potentially then tailor in order for fitting the deployment and testing providers.
Yes. And I think that's actually a good a virtuous circle, because people who consume the most average, the non-modified source have the easiest time. And the people who are most picky about wanting lots and lots of little changes are going to wind up being the ones who have either the most to pay for some third party or the most pain internally to continue to make those changes and to follow that source tree. I think that's a really good feedback mechanism between diversity of deployment, and ultimately we have as carriers to choose whether or not our difference in the way we make multicast work is something that is differentiating our company. And if it is, fine, good. We'll spend money on that because that's bringing money in. On the other hand, if that's just something from the legacy and there's really no need for it to continue to be differentiated, maybe those things will smooth out going forward. Right?
Okay, so let's thanks the speakers again.
All right, sorry.
Yeah.